Hi guys, can you hear me? Welcome. Fantastic having you here this evening. I think due to the weather conditions, it won't be 200 of us, but welcome. It's great to see first timers, but also returning members. So glad to have you. Let's go quickly through the usual stuff. How many members we are today? We are 1,000 plus. 1,000 and a bit, I think 1,050 or something like that. We are growing very fast, which is great. It will be great to know more of you, over coffee. Yeah, good catch. Good catch. Let's see the next slide. So, who are we? Who is running Bucharest AI in Romania? So, my name is Alexandra Petrus. We have some nicknames over here, just to give you a hint of what we do exactly in the team. I do a bit of everything. I have a product management background, focused on emerging technologies. So yeah, I do a bit of everything. I fix stuff with the focus on bringing a solution to problems. We have Raul. He has a background of mathematics, and we call him the entrepreneur just because he's in process of developing his own startup, and he had a couple of attempts before as well. We have Mircea over there, the technologies. Many of you know him already. He comes from a background of engineering. We have Silviu Moișoiu. You met him at the entrance. He's our learner, and he has a background in engineering. He's just finalizing his last year at the university. And we have Ioana, last but not least, which is our communicator. It's over there. She's taking the picture, so smile when you see her. She has a background in public relations. So that's us. Good question. Okay, Bucharest AI. What do we have on our agenda this evening? So, of course, you saw the registrations. We have the networking and pizza at the start just to keep you relaxed and, get a good vibe, because I presume you come after work and so on and so forth. It's important to get you here, ready to listen to the talks. Now we're going to have the open space challenges, which is like 10 minutes, where some of you, part of the community, comes here and presents its challenge. Of course, anyone from the community can submit a form and can actually join us in this space and present any AI challenge, or I don't know, if you need a staff on AI, if you need funds, partners, anything AI related, this is the place where we have you. We have the keynote presentations, which we have 2 this evening. It's fabulous to be able to have the chance to, see such powerful and strong speakers this evening. We have Marius, some of you may know him. He's fantastic in his job. And we also have FotoNation. We have Liviu over here, very talented research scientist and developer. And afterwards, we have the networking space again and pizza at the end, again, to keep you relaxed, to socialize, to meet more like-minded AI practitioners. Okay, where can you find us? Because it's important. So we are on meetup.com/Bucharest AI. That's the group where we sell our free tickets. It's important you know it because that's where we do our registrations, and we are usually overbooked without promoting the event. So yeah, which is great. We have the facebook.com/Bucharest AI Facebook page group, but it's important to mention that we also have a closed private group where you are accepted only after you talk with us and so on and so forth. It's important that we know you personally and your interest, AI interest. So do ping us if you want to join that group. We have the website, Bucharest.AI, and the global website of our network is City.AI. It's not mentioned here. And of course, we have our email address, contact@Bucharest.AI, where everyone from the team receives the email. So if you want to ping us there, or on Facebook or everywhere. That's us in a nutshell. I'm gonna let Mircea take over and present us the challenges and the keynote speakers. And great having you all this evening, guys.
Thank you, Alexandra. So hello everyone, I'm Mircea. I'm not sure whether you know the structure of our meetups. Currently we have 2 sections. One with community open space, called Community Open Space, where we have community members come up and present their AI-related challenges. This is an opportunity for you to collect feedback and get support from the rest of the community. We are actively looking or actively receiving your challenges on a web form. This is something that we will give you the link to the web form both at the end of the meetup and during our communication. At the end of after the meetup, we have a Medium article published every time, so you can get to see what was presented during the meetup and so on. Now, today, we have Andrei Țăranu. He is going to present his project AutoNet. And to give you a bit of insight about him, he's a product owner and value researcher at Condiment. And he is, this is something really interesting. He owns an impressive collection of toe socks, right? So it's a great conversation starter. Toe socks, if you didn't know what that means, yeah. He's a Java and Python developer, a coder, and today he's going to present you AutoNet. This is a project that you have started how long ago? About 3 months ago. And it is very interesting. He also has an incentive for you to contribute. He will tell you more about the reward that he's giving in his presentation. Now, Andrei, you will have 5 minutes for your presentation and we'll take 5 minutes of Q&A afterwards. There is also the opportunity to discuss with Andrei afterwards and get more insights from him. Raul is going to keep the time and he will show you when you have 3 minutes and 1 minute left. And that's about it. Good luck with your presentation. I'm going to switch to your presentation and the clicker.
Oh, yeah.
Okay. 1 second. And screen.
Hello. Hello. So I'm here to talk to you about a project called AutoNet. I'm actually calling it AutoNet as AutoNet sounds a little bit weird.
Okay.
I'm pitching this to you for recruitment purposes. So as you can see, the tagline is career opportunities for AI agents. You might also say that this is the place where AI goes to find a job and make some money. We're going to start with TensorFlow. Hopefully some of you are familiar with it. It's actually the most popular set of libraries for AI development. It has over 25,000 projects posted on GitHub, which is actually quite impressive considering it's only 2.5 years old. There are a few reasons why it gained such popularity within the community. One thing worth mentioning is that like half of the projects that are posted are of untrained models. So this is where hardware comes in, because developers lack the necessary computational requirements to actually train their models. Maybe they just have the one computer and they don't want to allocate that much time. There are a few options if you want to do AI development. You can build your own server, middle of the road type of system will run you about $9,000. For the same amount of money, you can go on Amazon and have around 2,300 of hours of development with 4 Tesla K80. Or you can actually use the most efficient platform as a service by Google at the moment, which is ML Engine. That's twice as efficient. All of these options are fine if you are working on a commercial project with corporate or VC funding. However, if you're an independent developer, or you're just bootstrapping a project, or you just want to do some AI research out of passion, the cost of training might be a concern. So let's talk about another option, which is using the blockchain mining network to train your model. Now, you may know that if you want to do cryptocurrency mining, you need the same kind of physical architecture like if you're training AI. So it's based on parallel processing, GPU-based servers, CUDA instructions. Now, this network, which has been created by Bitcoin in particular and blockchain in general, can be the biggest data farm ever. It's It's estimated at 15 exahashes, which is ridiculous. Yeah, what if you could train your model on this network and actually do it for free? That would be an interesting prospect. And the way to do that is by using a dedicated token. So consider, if you will, this type of workflow. You're a developer, you input your code into a version control system. Once you decide that it's ready for training, you publish it along with the description of what it does. From there, people can see it, and if they decide that it's commercially viable, they can invest in it, they can back it, and then they use the token to pay miners, which are running virtual machines with all the libraries for TensorFlow and references to the data sets. They train the models, they get published back into the marketplace, and then they go into production. The revenue that they generate is split between the developers and the investors. So it's actually a marketplace where developers can publish, train, and monetize their models for free. And it's a place where anyone can become a stakeholder of AI services, which is quite a good thing, considering people are currently looking for ways to gain economic stability in the age of automation, where human labor is becoming irrelevant. Anyway, you cannot do this with blockchain because of its intrinsic limitations and overhead. So we're looking into implementing the Markov chain Monte Carlo family of algorithms, which has been proven to be quite safe. And the project has surpassed the proof of concept stage. So we have successful implementation of distributed TensorFlow over TCP/IP using Apache Spark. So we can synchronize jobs by introducing a fair amount of latency. We are on course to join Iconic Labs in Frankfurt in June. They have set some milestones in place for us. One is the MVP, which is not an issue. The other is the reason that I'm here, which is so for an ICO, you need like a strong panel of professionals, not only to support your project with their performance, but also for marketing purposes, which I think is unfortunate, but this is the way it's done. So to that end, I'm offering 1% interest in this project to anyone who, by their contribution, will add to the founding team. So if you think this is interesting, and you know someone who might be a good fit, it might be worth your while to reach out. And that's everything, I guess. Thank you.
Thank you, Andrei.
Is there anywhere where we can find more about your project?
Yes, the white paper is almost done. You can get a teaser. I think they will share. Yeah, they will share the links also, the links for contacting me. So the white paper is not fully complete, but it's almost done, and there's a teaser where you can read more premises for this project.
Okay.
Any other questions?
Other questions?
Okay, thank you.
Thank you, Andrei. I'm going to invite here Marius. We'll make some room for the presentation. This is not better. Okay. And we'll have not that one. This one. Okay, so let me give you a bit of background about Marius, which is looking for USB. Marius is a research scientist and associate professor at the University Polytechnic of Bucharest. Okay, and he is teaching computer vision at the AI Masters in Faculty of Computer Science and Engineering. His research, he is going to present today part of his research in computer vision, and one of the greatest challenges that he has faced in bridging the gap between vision and language. Marius is also a publisher and writer. He has already published poetry and prose, 2 volumes, and I'll let Marius introduce himself and his work. Marius will have 30 minutes. Raul will be the timekeeper as well. And well, we'd like you to be very engaged. Feel free to ask questions at any point in time, or as you prefer, we could have them in the end.
So, any time or
yeah. Marius, good luck.
Okay.
Thank you.
Thank you. Hello, everybody. I'm really happy to be here. Thank you for inviting me to give this talk. So today I chose a very interesting problem, which is not solved yet in computer vision and artificial intelligence. It's one of the hardest problems that I'm facing right now, that I'm trying to tackle now, which is trying to find a link between vision and language. And I hope today to make you interested in this problem and try to maybe show you how difficult this problem is. Even though I don't have the answers yet, I definitely know it's the start of the new of a new endeavor that could lead to many other problems and maybe even a new scientific field, I would say. So let's start with one question. If you had a computer vision system that is totally capable of seeing and understanding the visual scene, what would you like it to do? If you give this image, what would you like that system to give you back? So one thing you could say, okay, so I would like the system to give me the objects in the image, and then maybe I would like to have the system tell me what it could do there in the image, I mean the actions, activities, events, the scene, understand the location and what's going on. And at the end, maybe I would like the system to give me a short story about what it might see in this image. So that's exactly what's happening in computer vision. First, we try to detect objects. So let's say that at this point in time, we are able to detect a lot of objects with high accuracy. Then we are tackling the problem of finding actions and activities, and now we are trying to infer a possible, I don't know, caption or description of this image. Let's look at this tiny image. What do you see there? So if we look at this small image, we really cannot say for sure what's there. At least I cannot. However, once I see the larger picture, I immediately could infer what's there. And actually not just infer. When I'm looking at those pixels in the larger image, I'm actually having the vivid experience of seeing. I'm actually seeing something there and seeing something. So what am I seeing? On the right, I see just pixels. On the left, at the exact same location, I see maybe a man or a woman or a person in some story, in an environment, in context. So context is really, really powerful. And what is context? That's one of the biggest challenges. We don't really know what context is, but it is a story, some sort of world in which these pixels live, and they get a meaning, and all of a sudden we understand what we are looking for. But again, you could imagine that this patch comes from everywhere else in this image. So this image is made of these patches that make no sense. Together they start making sense. Well, this is interesting because a lot of people consider that by just looking at the patch, you can tell what's there, which is not really the case. So let's go back to this image. What do people see when they look at this image? So what I did yesterday, I had this class, Introduction to Robotics, and I got this idea. I said, okay, let me look for some images online. So yesterday I found this image, and I asked my students to write in a few words what they see in this image. I said, okay, I'll give you 3 to 5 minutes. So they took about 3 to 5 minutes, and they wrote. So there were about 10 people in class yesterday, and they sent me by email their answers. With their permission, I will, well, without giving their names, I will show some of their answers because they're really interesting. Some of them are in Romanian, so please forgive me. I was not translating them. I did not translate them because I just wanted to leave them in their original form. So, okay, let's see what they say. What? No, sorry. Okay, so someone is cooking, probably. Who is cooking in this image? One person says, a lady. Another person says, the father. Another one says, the mother. Well, they were giving these descriptions independently. I didn't let them talk to each other. And also I just said, okay, just write what you see, okay? I didn't give them any constraints. Another one says, is more accurate. It's an adult blonde Caucasian female. Okay, very interesting. Now, next question. What are the children doing? Now, obviously there were some children there. Well, some learn how to survive in nature. Another student says, well, they exchange opinions about what this adult is doing. Another one says the children are looking at the lady, and the one with a blonde Caucasian female answer said she was not saying what they're doing, but she said that there are 3 children of different ages and race. So you see, and these are very serious answers. They're nice. I mean, if I gave my own answer, probably to be one of these and to be different. But what's interesting is that they all see the world differently, even though they have a very similar background. So if I was inviting people from very different backgrounds, with I don't know, different age, different culture, different schools, they will probably give even more varied answers. So these people are all most of them have graduated from computer science department, and now they are AI master students. So you would expect them to see the world in the same way, but they don't see it in the same way. Let's go further. When is this happening? Well, they are ready to spend the night in the tent. Another one, well, it's morning. Another one, well, they just woke up. And then another student says, well, because of the sun, it's actually evening. And another person said, well, looking at the sun, we can say it's afternoon. So we covered the whole day. From 10, well, at least it was not night. But it's very interesting. It depends. Maybe the same person on a different day would have said different things. So what else? So there was this student who was becoming very creative. She said the mother teaches them to appreciate everything that happens, the smell from the wood, the beautiful light that surrounds them. So what is interesting is the following. So what I'm trying to point out here is not that we see the world in different ways, is that there is this interesting point where it seems that we break from reality. I don't know what reality is, but let's say we break from the physical world and we go into this other world, the mind world, when we express opinions, we start seeing things at different levels, but it's not really sure when this happens. So what does it mean to describe something into language is really a very deep and interesting question. So what do you want that system to do? Okay, maybe say this is an object, but they call that person a mother, a father, a lady, a Caucasian blonde woman. So what is that person? Okay, everybody agreed it was a person, but that's not sure either. Well, it could be maybe in the age of tomorrow, it could be a robot in some science fiction movie, and that could be a scene from a science fiction movie. Okay, but we don't know that at this point. But we don't know. So, so there is this transition, very, very interesting transition into this mind world where we see certain things at different levels, but they're not actually in the image. And that's really interesting. We try to form a coherent story, which is good, but this story does not necessarily fit exactly, maps exactly to what's in that image or in the real world. Okay, let's play one more. What is in this image? Okay, if we look at this image, we really don't know what it is. Maybe we can make a guess. In any case, let's move on. So we have another example. We have young people here doing something. So let's see what these students are saying. Well, one is very creative. It says, 4 people sit on the grass, maybe they're in a park or maybe on the football field. And they just play football. And now they got tired, so he's getting really creative. Okay, I understand that. He's aware he's creating that, I'm pretty sure. But the one on the top, he's trying to be very, very careful. Even though I didn't tell him to be careful, he actually figured it out. He said, okay, I know what this guy wants from me. He wants to fool me, so I'm just going to be really, really precise. I'm just going to tell him what's in this image. So he describes very carefully what could be true, what could not be true. Then he says, okay, so there are 2 people with different colors of hair, and then the blonde ones have sunglasses. Really, sunglasses. So he saw the sunglasses. So these are the sunglasses. okay, that I asked you, what are they? He saw them. He said he saw the I saw the sunglasses too. But I see them here, even though I didn't do anything to this image. It's the same resolution. I didn't modify it in any way. I didn't take any information out. So, let's move on. What is going on here? See, computer vision spent a lot of time here. Detect objects. And then there are other people who are doing a lot of work on language. And then you have different departments, you have different compartments, you have people who say, okay, you do vision, I do language, okay? So, have a nice day. In reality, there might be a continuum here that's not attacked. Well, I defined it. I said, okay, let me be creative in this talk. I really want to push it further. So I said, okay, maybe there is something else, visual language. I don't know. Maybe there'll be a new field tomorrow that we will all study. The same way computer vision started. Do you know how computer vision started? It was a project in 66. It was a project in 66 given by Marvin Minsky's student. Then he was a professor, Paper. And he gave his students a project. He said, okay, by the end of the summer, you should solve computer vision. I mean, basically, look, you have these images, so you make a program that returns the the objects present in this image. That was a summer project. And he believed his students could do it. Maybe not in a summer, but in a year. Now, it turns out this field was not solved after 50 years. It was after 50 years when I was really thinking about this experiment, and I said, wow, it's one of the last fields solved by AI, or, AI, neural nets had a big impact in AI, but they had an even bigger impact when they solved certain problems in computer vision with AlexNet and the ImageNet challenge. So, and he started in 66, and he thought he could solve it. So, I feel it's kind of the same way now. Maybe it's not going to take us 50 years, but it's definitely something much more serious than it seems. Okay, so now let's think about some use cases. Now, let's say that you have this system, now you build this system, it's great, it's doing well, and it's able to give you objects in the image, actions, activities, events, scenes. It is also able to describe it in words. So what would you want it to do? Now that the scientific problem is satisfied and you are, you're happy that you found all the answers. Think about the use case. What could be a good use case? Now, after we saw that language is not just language, it could be something that's really precise. There was a person in that image. Okay, that's probably true. With other opinions about that image, which might be true or not. So language could go from truth to being very creative. Which one do you want? It depends on the use case. So that's how we should think about use cases. When I think about use cases in AI, because AI relates to people, I think about people. So I'm imagining, okay, what do I want people to do? If I want people to move bricks, then I think about robots that move bricks. But if I want people to talk to me, if I need people to talk to me, then that's a good case for a use case for AI. So whenever I need a person to look and talk, it's a good use case for AI. Simple. Okay, so let's take the simpler cases, not the simpler cases, the cases where we really want the truth. Well, in emergency situations, I don't want creativity. Okay, I don't want you to start talking and describing what you imagine. I don't want you to be Shakespeare or Hemingway. I want you to tell me what is going on. Is this lady well? Is someone attacking my house, or is it just a cat? Is a flood there or not? Is there someone in the flood? Are there animals? How many animals? How can they? You said you could imagine putting cameras, or you could imagine having drones flying around. Yes.
Why would you rely on a subjective interpretation of an image rather than looking at it yourself?
Well, sometimes you're not there. Sometimes you're not there. You're at work, or you are sleeping at night, and you have cameras around your residence, and you want the system to alert you when something serious happens. Well, those things happen very rarely. You don't want false positives. You understand what I'm saying?
Yeah, true, but I'd like to see a video of it.
A video?
A video of it.
Hey, can you speak in the microphone because we are live
I-
streaming and it's important so people at home hear it?
Yeah, so the initial question was, why would I rather hear a story rather than seeing the video myself? And why would I not choose the video?
Oh, I understand.
And the reason of my question is that whenever I see the video, I rely on my personal subject interpretation of.
I understand. Okay, so here's my answer in the case of someone attacking your house. If you are sleeping, you cannot see the video because you're asleep. But the camera sees this guy for you. It alerts you. Then you look at the video and see if it's true or not. Okay. However, you don't want the system to alert you every 5 minutes because the wind is blowing. You want this camera to alert you only when it's for real, or with 95%, 99%. So you see a case where you're not there, but you want to know what's going on. You cannot watch everything. Let's say you have this big forest. It's yours. It's all yours. This rich person has a large domain. You cannot watch 1,000 screens per second. You don't want to employ 1,000 people to watch for you. I mean, you could have an army of people watching, but maybe they have something else to do. Maybe you don't want to spend your money that way, you understand? So you have these cameras, and you would like them to understand what's going on for you. And then you judge for yourself after you are, okay? Here you could have children. Again, not all children in this world are monitored. And it's normal if you're a parent, and if you have the money, you can say, okay, I'm giving my children to this kindergarten that have this system, very good, very powerful. And I feel safe. So people invest in what they care about. You care about your home, you care about your grandmother, you care about your children, authorities care about traffic, and so on and so forth. But in this case, you don't want creativity. You don't want this system to give you this nice poem about this guy attacking your house. So in this image, you might want your AI to say, I'm afraid your son missed school again. That's not among the ones they actually pointed out. But in any case, well, in some other cases, you actually prefer the system to be talkative. You want the system to tell you all kinds of stories. It doesn't matter if they're true or not. You want to be entertained. You like legends. You go somewhere, there's this castle. You want to hear all these stories about this castle and Lancelot doing all these things, even though they're probably not true. But you like it. You like the experience. It's like being in a movie. Okay? So in that case, you really want, if I have an AI system, I put my headset on and I walk around Paris or around, I would like my system to talk to me, to explain all kinds of things, to guess my mind and start talking to me, not reading from a book, because that would be not nice. I would not like it. You don't like this system that just reads automatically from a book without knowing what you want, without knowing what you're looking at. You want the system to be to pay attention to you. It's like a person. You want the person to understand what you like to hear. Okay, so in this case, you want the opposite. You want creativity. So that's why the understanding of the problem helps us also think about the right use cases and understand what is going on. What does it mean to describe something into words? Because people, when they write papers on the subject, they don't spend time doing this. They go through the introduction very, very quickly. They go to the related word very, very quickly, and they start talking about all these complex systems. To solve a problem that they have not defined, they might not understand, but they don't have time for that. So that's why we have to take time. So in this case, I just looked for stories about Notre Dame. So I found this interesting story how Saint Denis lost his head, and then his body walks all the way to the mountain, and this is the statue that talks about this event. And actually he gave this sermon, this is science fiction, it's magic, and they say that that's where the Montmartre got his name, from mountain and martyr. Okay, so it's interesting. So maybe you want an AI system to know that you like these kind of stories and tell you. Then let's talk a little bit about our work on trying to do this, from video to language. And we started to solve it. We started to tackle this problem without being, for the first time. And that's how we started learning our lessons. And not just us, others who try to solve the same problem. So how would you describe a video in sentences? So at the time when we started doing this, we thought about it, but there were other things that we learned on the way. So let's see. First, we created, using LSTMs, we created a system that encodes video, goes through all these features, encodes them, gets to this embedded space, and from this embedded space, you would expect to reconstruct language. So this would assume that there is a common embedding between video and language. Well, that's a nice assumption to make. It's just that video comes from the observable world, whereas language could be in this creative world. So something is not perfectly matching here, but it could be true that there is something common. It's just, it might not be so simple. Now, so we trained this. We trained it on a data set with about 10,000 videos. For each video, you had about 20 ground truth human labeled sentences. So you want the video and output one of those sentences. So we had, for those of you familiar with computer vision, we divided every frame into several windows. We took the full frame. We also took sub-windows. We passed them through some neural nets that created some features. Then these features from each image, we put them into an LSTM. We have this recurrent net. Then this encodes what's in this video, and then it decodes it into language. So you encode it, and then when you decode, you get language on the other side. It's pretty interesting, and it's actually not doing a bad job at all. We also used an object detector after that, and we combined it with the other features that were not using any object detector. Then we also thought about doing the following. We wanted also to focus only on language formulation, how we formulate language, not on content. So if I give you a broken sentence, can you produce a fluent sentence out of it? And that should focus only on how you speak, not how related it is to reality. So someone just keep talking and say, talk in a beautiful language, even without saying anything meaningful. But you need that capacity to connect words in a nice sounding way. So that's what we tried here, to give a broken sentence and try to recover it. And that's when you really have the ground truth. So we did it in the same way. We encoded the broken sentence, and then we try to recover the correct sentence. And these are just a few examples. So in red you have the input, which is broken, and the woman man. So the network now has to create a sentence out of this. And it creates the sentence, a man and woman are talking to each other. So it's fantasizing. But this could happen in many cases. So it learned the general cases, and it talks in readable English. Now, the truth was, or one of the labels from a human label is, a man and woman are walking with their bikes. So it's a different story. It's less likely, let's say, but both of them are English, are okay. Or a person unholding. It's a broken sentence with missing words. The ground truth is a person holding an umbrella on a street, and the network was generating a person holding an egg in a bowl. Okay. Or crosswalk with a man in a video game. It makes less sense. A crosswalk with traffic cones at night. Well, this one doesn't make that much sense either. But in any case, so you could do something with this. So the idea is that if you generate somehow a broken sentence, you could be able to fix it. Well, this reminds me. At some point I took a class in Introduction to Cinema, and the professor was saying that making a movie is a collaborative effort, and it's art, but it's like a big factory. It's like lots of people there are working together to create a movie, and the script is made by many people. One creates the idea, the other one comes and actually writes the script, and then they have these script doctors, which take the script and correct it, and they add different things. They cut, they change certain types of language. They are experts at different types of characters, and so there are many people creating this script, and I'm thinking maybe in our heads there is something like that too. Maybe we have many components that are fixing little things until we speak something that's fluent, it makes sense, it creates an image in the other person's mind, and also is related to what's going on. I don't think it's just one network. I think there are many, but we are just at the beginning. So it's really exciting. So we were thinking about doing this. So first, we have this language encoder, language decoder. This could be, by the way, this could be trained on a data set such as Wikipedia. So you can have only a language data set on which you can learn a lot about language without touching video. So you can really learn the skill of speaking, let's say, or writing, not speaking. And then you can have a smaller data set on a video where you have video to language pairs, and then you can use this knowledge combined with this to get better formulations. then this would be a complex system in which we try to connect everything. The idea is that we want to have this latent, hidden space as close as possible between language and video, hoping that by keeping them together, we get a better decoder. We get an explanation in English that is more coherent, and it's also connected to what's going on in the video. So these are some examples. This is ground truth. What we call ground truth is a human. And, okay, let's go back. And this is what the net is generating. Now, the interesting thing is that this is not wrong, even though it's not like the ground truth. And again, it's this problem, is that there are many possible descriptions of a scene, an image or a video. In this case, we work on video. Well, this is not correct, but certain features, you have a monkey talking about it, okay. A man is throwing the ball into a goal. You have the goal, you have the man, you don't have the ball, but you have the ball. It's interesting. A person is showing how to make a toy. Very interesting. Actually, I think this is better than this. A chef in white shirt is talking about how to cook a piece of meat. This is more detailed than that, and not bad at all. So you have this output, which is really interesting. The cartoon characters are standing. A girl cries while another talks. This is different, but they are all possible. Both of them are possible. She walked down the runway. Models are walking down a runway. Very nice. And these are from the test videos. So these are videos that the net did not see before, obviously. A man is surrounded by a woman, and a group of people are raising their hands. Okay, now if we look at the numbers are pretty low. 100 would be maximum. But, and this is the second discovery. The first one was about how complex language is, which you would expect. But then when you start computing all these, people are inventing ways of measuring how good these translations are. And the problem is that these numbers are not really, these measures are not so good. So we are very close to state of the art. This is state of the art, 28 for Meteor, the higher the better. Blue 440, and we are at 36. Compared to this, we're at 26. And in 2015, the best was below what we are today. So the field is moving. But then, you look at these scores, and you see the way they are computed. And the way they are computed is too low level. Basically, you score well if you generate a sentence that's almost identical with another sentence from the ground truth. Now really, you saw the sentences produced by those students. How different they are. And if you bring another person, you'll see another one. If you bring another person, you'll see another. If you take 7 billion people on this planet, they will produce 7 billion sentences. So what type of scores are these? They do not make that much sense, but you realize only after you look at the numbers and you start thinking, it's like, oh my God, what are we doing here? Look, someone wrote a paper very recently where they actually demonstrated somehow that you don't want, that having higher scores doesn't mean you actually do better. And this is the score that humans get. So humans are actually the worst when compared to this score. So obviously the score is not good. So what are we doing? So really, we are at the beginning. Now, let's move forward. So here there are some examples where the baseline is actually giving a very nice sentence that is pretty general and probably true, but the better system is giving variety. Unfortunately, we don't have much time, but I'm at the end. So this reminds me of something I've read some time ago in this book, very nice book, The Language Instinct by Steven Pinker. And it was about Noam Chomsky, and he's one of the most cited authors in history. And he's a great linguistics scientist and mind scientist and philosopher and cognitive science. He's the godfather of modern linguistics. So the first idea, which he said a long time ago, he said every sentence that the person utters is brand new. Language is not a repertoire of responses. So language should not be judged as with these kind of scores. Then, children develop language without formal instruction and are able to interpret sentences that they have never seen before. which makes me think that actually language and vision evolve together. Probably vision is first, but there is a time when they evolve together, and probably even later in life. Just imagine after you got a lot of experience, you look at people, you see other things that you had seen, I don't know, 20 years ago, when you didn't have that experience. So vision is much higher than we thought. So that's what I'm thinking. I'm thinking that we observe the world, but having a coherent image helps us understand what's there, helps us see those pixels, what they mean, sunglasses, because there is something else that's missing here. My feeling is that there's something that's missing, we just don't see it. We try to find what's there. And now, my last example. And I gave this image to my students, and this is what they said. So, very interesting. The first one was looking at this metaphor. So, there's an elephant, okay, in the room, and people are talking around the table. So, the first one got the metaphor and said, okay, there is this metaphor of the elephant in the room. Nobody sees it because they are really busy with other things. Another student says, oh, there is an elephant there, and they all look nervous. Or another student finds another explanation. Someone photoshopped an elephant in the room, probably to make us notice the huge, useless space in the room. So everybody try to find a coherent story. You see two things that just don't fit, and we try to put it together. And then this guy doesn't care about context. He says there is an elephant, the windows are dirty, and he's just trying to describe what I see. This is what I would see. I see different sciences sitting at the table of knowledge together, not seeing the truth that stands between them. This is what suggests, when I looked at the image after all this presentation that I made, I got this one. It fits very well because this is computer vision, this is language processing, this is this science, cognitive science, and there is something that's missing, and we feel it's there. I got this feeling, and this is what we are trying to discover. So thank you very much. And
we have two questions over here.
Hi. The last sentence is the one generated by the AI, or I didn't...
No, this is what I say, what I would write about that image at this point.
Okay. Thanks.
So if someone asks me, now Marius, you are one of the students, write what you see in this image. This is what I would write.
Okay, I actually have a question. Why do we need to generate only one description? If we take, for instance, a use case when you're searching for some parts of the videos, like a video editor or just person searching for images, and you want to see like people standing near each other. Maybe it is worth to generate as many as possible textual explanations, so it will be in the search results.
Yes, if you are thinking about searching in a data set, I agree. You are thinking about a visual search, like a question and answering type of problem. But in the type of use case I gave you with a tour guide, you don't want this tour guide to give you 1,000 possible. You want it to make sense. For example, when you're talking to someone, you want this person to say something that's meaningful, then to stop and let you speak. You don't want this. So your application is great, but it's not fitting in these other cases where you want to have someone describing to you as you walk on Calea Victoriei or Champs-Élysées. You want someone to just look, Marius. You see there is this building with this nice history. This is Notre Dame. This is palace or.
Well, I got your point, but where is your examples of answers from students? They all see it from different facets.
Yes.
Maybe what it can learn is basically several things. First is to describe what it sees, and second is actually to identify the facet.
Exactly. So maybe you could have you could put a personality around this AI, and you can tune it and tweak it. You can say, okay, I want this tour guide to be very humorous, or I want this tour guide to be less talkative and give me precise location. Say, look, this is this street, and this is what happened then. Oh, I don't want to know about history. Just tell me what it is and how do I get to Eiffel Tower. Okay. So yes, you're right. You need to. Language it depends on many things, not just on what you see, on your personality, on what you have been through in life, on your experiences. It's also about you, not only about what you see. So.
Can I step in a bit?
Yeah.
On the same topic, I'd rather have one description. For example, let's take fake news, right? We have events that take place as in videos, images, whatever. And we have a guy from, I don't know, New York Times, one guy from Washington Post, which sees the same event, the same video, but have different point of views and different perspective, and the article that they write is totally different, and the point of view is totally different. Using this in presenting events in one single point of view might actually work.
So you want, instead of having 10 journalists with 10 opinions, you want just one? Well, in that case, I think it's an advantage to have to see history or events from many viewpoints.
Yeah, I'm not saying having multiple opinions or point of views on a problem or a thing is bad. But for example, on the fake news one, I would rather have one which is the truth, sort of, and we all see it that way, as in, you name it, some kid or something happened and it's bad. It's not bad because I'm an American, or it's bad because I'm a Russian, you know? It's bad
So that's what I was also trying to say, that in some cases you just want one answer.
Yeah.
And usually when you really want the truth, the answer is simple.
Yeah.
Because it's addressing a certain yes or no question that you are trying to ask. But sometimes you want creativity, like in art, for example.
Yeah, true, because I would also think in using this in, for example, Jules Verne. I would use this to actually create and use it reverse-wise, make this movie for me. Make this story and make this
That's
movie
interesting.
and let me see it.
That's very interesting.
Okay.
That's very interesting.
Hi. Thanks. Thank you for your talk. It was very interesting. And I want to ask if you see any connection. Not sure if you are familiar with the indeterminacy of translation. It's actually a thesis, and it's done regarding the subject that it's almost impossible to have one version of a sentence from one language to another, because you can't exactly see what was in the speaker's mind or something. Do you see any connection with this?
I see connections every time I'm thinking about translations, because language is, I'm thinking that every word actually means a story. Behind it, there is a story. When I ask myself, when I use the word car, what is a car? It's the stories, all stories related to that car that I've been witnessing. So when I'm thinking about a car, I see my own experiences of cars. I didn't learn about cars from dictionary. I relate to my experiences. Someone from a different era, when he thinks of a car, that car looks different, different streets, it's a different story. So languages come from cultures. Cultures are formed in different parts of the world. That people are different, they live in different ways, they have different technologies, different ways of behaving. So there is no pure translation of words. Maybe a few words you could say, like love or some universal, maybe there are these universal essences. But house, a house for someone from India might be different from house from someone from the United States, or car, or street. It's a completely different story. So the word is a placeholder for a story. Now you would say, if that's true, how can we communicate with each other? That's another interesting question. How can I talk to someone when what I utter is taken slightly differently on the other side? Well, my opinion is this. As long as we do not know that we disagree, we agree. It functions, that means we agree. So, my translation of what you say, put in my universe, functions or it breaks down things. Because if it functions in the sense that it makes me feel that I want to come back to you, and again, it makes you feel that you want to come back to me, even if the stories are different, it works. It's like a mechanism. So in some sense, language is not to communicate pure information. I don't believe that. Some people say that. No, I think language is just to connect mechanisms that function together. And these stories can fit, even though they're not the same.
Okay. Yeah.
So related to your point, did it ever occur to you that maybe the language part comes second in line of this importance? I mean, did you ever think that you could create a new language just by letting a computer tag himself what he sees?
New language.
New language. Letting a computer tag things by himself
But when you
and interpret the context.
when you are thinking about language, so a new language is just a new language if it's like other languages, right? So it depends on what you mean by a new language. If it's a language that's a sequence of symbols, okay, but that's another language. It's nothing new. Just another language added to the pool of languages. Well, actually, scientists believe, Steven Pinker talks in his book, I mean, he has a very, very nice book, Languagistic, and he says that after a lot of research, he and other scientists found out that actually babies are born with this language instinct, with some meta-language, and it's natural for us to speak. We don't have to be taught. We get a few, we hear other people talking, and then we figure it out. So we can talk immediately. We have a meta-language somewhere in our minds, in our brains, actually.
We have one more
So I
question.
think it's strongly related to experience. Just a computer by itself, without touching the world.
One question. What about the deaf people language?
Okay, so that's another language. So I have nothing to say extra. It's a language. It's not expressed by sound, but it's still a language. These people communicate to each other. What can I say?
Just a little bit of a
Yes.
a little bit of a clarity. So the reason I was asking is because you presented to us all that effort of
All that scoring of interpreting correctly an image, but in the end, that only by interpreting a series of images, you can invent a language of its own. I mean, why this importance of trying to match a certain description?
We just don't know how to do it. So you want to keep it simple. You want to have this nice objective function when you put in the systems that learn by themselves, that you can do mathematics on top of them and optimize parameters. So you need to take all these ideas and put them in the language of mathematics, and this is the problem. How you make the transition. So those cost functions, they are easy to compute. They make sense, but they are inspired, I would say, from the classification, from what machine learning did over the years, classifying things and trying to measure, this is the correct output. There was a correct output. But in this case, the problem is that there is no correct output. I mean, there is output that's obviously wrong, but it's not just one correct output. There are an infinite number of sentences, phrases, and texts that you can write about an image or a video. Infinite.
Hi, thank you for this. What do you anticipate will be the development of AI in Romania? I know it's a bit more general.
I anticipate that, well, it's what I see. It's easy to anticipate when you start seeing things. So I see a lot of interest both in the industry and also at the academic level. So I see many companies that want to work on AI-related problems, either implement solutions, create new solutions, or even do research. And I also see a lot of interest at the academic level, and this could be clear in many ways. I mean, there are many cues that show this. One is it's very obvious. Our AI program at the University Polytechnica of Bucharest increased almost overnight. When I started teaching there in 2013, in my computer vision class, there were 5 students coming. Only 2 were actually interested. And now I had constantly above 30.
Wow.
And our AI program has probably, there are some students from our program here, has probably above 40 people, or around 40 students, which shows interest and shows a lot of, shows that something is happening. And when you see the young generation doing this, then it's clearly sign for a future.
Also on weather when it's snowing outside. Also when it's snowing outside and you almost have 200 people in the room, actually kind of shows, the interest of AI in Romania. So yeah.
And You know, when there is an empty space, you usually put the best new, and the new technologies are coming, right? So in Romania, you have this great interest in technology. And I'm betting on AI because Romanians like technology, Romanians like mathematics, Romanians are excited about challenging problems. They're good, you know, they go overseas and have some of the best students in mathematics, some of the best in computer science. We have a very, you know, a mind that is hungry for information and for discovery, and I think there is nothing to stop it from happening.
Let's see some other questions. Okay, yep.
It's not actually a question, but more as an advice. Psychologically, it has been demonstrated that when people use a certain language, they tend to act like the people from that culture. Let's say if I would speak German, then I would be more. I wouldn't emphasize things so much. Where I would have a more direct approach. While if I would speak Italian, then I would tend to gesticulate a lot, to use descriptive words quite a lot, right? And I think it might be interesting to be able to tune the apps that are going to use this part of AI to be culturally based as well.
That's a very good idea and good advice. Thank you. So, from what I know, the body language speaks actually much more than our mouth. And the body language does not come from our conscious mind. It's coming actually from our subconscious mind, which is much greater. So I believe that actually the body language says, and we understand body language even though we don't know why and how. So it's we talk to each other through body language without realizing it. And it's possible that we talk to body language much more than we talk to words.
78% body language. Yeah.
Okay. It could be. I would say 9.
So we can take one or maybe 2 more questions right now. Or we could leave it for the
next
networking session.
Yeah.
Thanks a lot. Thanks a lot, Marius. It was awesome having you here, and it's been very insightful. We'd like to have you in the future as well. And right now, I'd like to invite Liviu from FotoNation. He's a research engineer specialized in machine learning. He has been contributing throughout his career various technologies on object classification, object detection. Okay. It is estimated that his work is in around 25% of the. Yeah, I need to be in the camera. So his work is in about 25% of the smartphones shipped in the entire world. He holds a PhD in electrical engineering, and as I was saying, he's currently working on FotoNation. Let me give you some hints about FotoNation. There are some very interesting facts out there. So FotoNation holds over 900 imaging patents, and 60% has a 60% high smartphone penetration. In 2004, they have launched the first red eye reduction technology in the Nikon cameras. And by the end of 2015, FotoNation was embedded in 2.3 billion imaging devices worldwide. That's a lot. In 2009, Samsung Electronics started using a face tracker solution from FotoNation in their devices. So if you have a Samsung smartphone, you probably have something from FotoNation in it. And Liviu will be talking today about revolutionizing imaging with AI. And as part of his presentation, he will also do some demos, and you'll also be able to see some of FotoNation's demos after the presentation. So let's give it up for Liviu. Thank you.
everyone, I'm Liviu Dutu. I'm an R&D engineer at FotoNation in Bucharest. Do you hear me? Yeah, okay.
Not through the mic.
Not through the mic. Yeah. Okay, this might not be on. How to turn it on? Okay. That's it.
Okay, better?
Yeah.
A lot better.
Okay, so I'm an R&D engineer at FotoNation in Bucharest, and today I'm going to present you some of our application in machine learning and artificial intelligence within the areas of computer vision and computational photography. So first of all, a few words about FotoNation. So FotoNation is the imaging division of US-based company, Xperi, and among our colleagues are DTS, one of the leading audio technology providers, HD Radio, the US leader in digital radio, also infancy, a semiconductor and packaging company, and Tesla, our IP licensing division. So back to FotoNation, here's some numbers that really define us. It is estimated that FotoNation's computer vision and imaging technologies are present in more than 3 billion devices worldwide, with a smartphone penetration rate of 25%. So these amazing results are backed by more than 1,200 patents and more than 1,000 many years of experience. So beyond these numbers, what truly characterizes FotoNation is our unique, I would say, ability to combine machine learning and artificial intelligence with edge computing. Because most of those 3 billion devices you saw earlier have the intelligence on the device. So all the computations are done on the device. Yeah, right? So no need for expensive GPUs or risky cloud servers. And all of the applications, or most of the applications that I'm going to show you today, are built to be deployed on device, right? So it's important to understand that the machine learning activities and the machine learning applications that we develop at FotoNation are especially designed, customized, and optimized in order to run on embedded devices and still offer you the best of the quality. We also have extensive experience in hardware design, and most of our machine learning solutions are accelerated by dedicated hardware, and it's this combination, this hybrid combination between highly optimized software implementations of our algorithms and dedicated hardware that is one of the FotoNation's unique features. Okay, so enough talking, let's move on to the real applications. Okay, and the first application I'm going to present today is related to FotoNation's driving monitoring system solution. So it's a fact that 80% or more than 80% of the car accidents worldwide are caused by drivers' inattention. So this number, this percentage, could be greatly reduced if we could have the car somehow sense its environment. Right? So one step, we take it one step at a time. One step towards this is to have a computer vision system based on some in-car camera that is able to monitor the driver and act accordingly. And that's exactly what FotoNation's driver monitoring system solution does. Featuring a face detection module that can run in a wide range of head poses, and using machine learning to create this face model based on face feature points, we enable the estimation of head pose orientation, eyelid closure, gaze, and many other useful information that can be used to predict the status of the driver. Also, our solution it works well under varying light conditions, and we also say that it's flexible to the camera. So you can put the camera basically everywhere near the driver, and it still works. Okay, let's see our DMS solution. Yeah, that's me. So you see, the face is properly detected, properly framed. It is tracked from one frame to the other. The feature points are detected, and based on these feature points, we deploy a convolutional neural network to estimate the gaze, right? So we estimate the position in the car, the location in the car where you're looking. So beware, once you have this technology in your car, you won't be able to text and drive. Okay, so moving away now from DMS and automotive, one of FotoNation's traditional areas of expertise and areas of excellence has been mobile, where, as I said earlier, we have a penetration rate of more than 25%. And within the area of, within the context of mobile, one application that really demonstrates FotoNation's expertise in computer vision and edge computing combined is face analytics. And our top face analytics solution features 3 layers. The base layer is a state-of-the-art face detection module based on a unique and flexible architecture of staged convolutional neural networks that is optimized and customized to give the best trade-off between speed and quality. On top of this, or once we detect the face, our face feature detection module kicks in and starts detecting over 90 facial landmark points, and based on this it creates an accurate model of the face. And then, last but not least, our face classification module comes and fully characterizes the face. It says the gender, the age, the race, whether you're smiling, blinking, and up to a certain degree, even the emotion that is expressed. Okay, let me show you a quick demo of this face analytics. Okay, so you can see that it detects my face. Oh, sorry.
Duplicate your display. Duplicate your display. Maybe this is a secondary.
You did that for me too.
What did you do?
Yay.
Okay, back on track. Okay, so now you can really see. So you see the face is detected, the feature points, the facial landmarks are properly positioned around my face, and you see that the network says I'm a male Caucasian adult, which is okay. I'm smiling, I'm blinking, I'm happy, or I'm trying to be happy. Okay. So you see, it's also resilient to occlusions. It holds the face, it traps the face, even if I have half of my face covered by my hand. It works for a wide range of head orientations. See? It also goes 180, but I'm not going to do that demo. Okay. if you want to play with this, or maybe our other demos, come visit us, come talk with us, FotoNation, after the presentation, and you can do, you can try to break it, maybe, if you manage. So yeah, that's how it works right now.
What does YNP represent on your?
The question is, what does Y and P represent on the face? Y is the yaw of the face. The yaw is the orientation of the face along this axis. Okay, and then P stands for pitch, which is the orientation of the face along this axis. Okay, you see, if I have positive pitch, negative pitch, zero yaw, or maybe. Yeah. It also predicts the roll. The roll is the orientation on this axis. Okay. So please come and try this solution and ask any questions you like. Okay. A natural extension to face detection is, of course, body detection and body segmentation. And using advanced but highly optimized neural networks, we have both technologies, as you can see here. And we're going to see a movie, okay? You can see that while body detection requires putting bounding boxes around the objects, around the bodies, body segmentation requires correctly classifying all the pixels of the object of interest. Yeah, so it's one step next, right? It's the next step to detection, segmentation. Okay. You'd say, why would I need segmentation, right? Okay, I need body detection. I have to know, as Marius said, there's a person near my house, maybe a thief, but do I really need to segment his body? Well, in certain cases, yes. Because here is a static example of our body segmentation solution. And even though segmentation is a much harder task than detection, once you have it, it really pays off because it allows you to do cool stuff like this. Yeah, you see? We segmented the body and used the segmentation as a mask and blurred anything else. And so it results in this amazing bokeh effect with this 3D look here. Okay. We also have a demo on smartphone for this bokeh effect. So come visit us after the presentation to play around.
Is this acceptably fast? Sorry.
Is this acceptably fast? I would say yes. You don't want the bokeh effect in real time. You want to take a picture and wait maybe 1 or 2 seconds, and then you have the bokeh effect. Yeah, no, it's not minutes. It's 1 or 2 seconds.
Thanks. Sorry.
No problem. Okay, so we saw that body segmentation enabled the bokeh effect, right? And talking about technologies that enable some other technologies, FotoNation's strong experience in face detection allows us to use face detection as an enabler for something even bigger, which is face beautification.
Bring it on.
Yeah. So, a few words about face beautification. Along with face detection, beautification is one of FotoNation's traditional lines of products, very present within the Chinese market, where basically every smartphone, when you turn it into selfie mode, it automatically beautifies your face. And within the Chinese market, FotoNation is the main technology provider for these types of solutions. Okay, let's see beautification in action. So that's the original image. And then we start playing around with colors. We can remove imperfections, make it look smoother, make it look thinner, so on and so forth. Add makeup, enhance the eye, whiten the teeth. Anyway, all kinds of beautification features that you'd want, we have them. Okay, so that's before and that's after, right? It's subtle, but it's there. The beautification is there. You can see it, right?
It's already beautiful.
Yeah.
Exactly.
Okay. So beautification is clearly a smart thing, right? A cool thing, a smart thing. But you see, there's a problem here. The problem is that the problem is that the features we use to modify in order to beautify the face are handcrafted, right? They're mapped to some image, to some standard image processing operations, and moreover, the values of these features have to be picked by hand. We have an average which works for most of us, but if you want to do fine-tuning, you'd have to go and change these sliders by hand. Okay, so this is smart, but it's nowhere near intelligent, right? Because the photo enhancement of tomorrow has to be subtle, but also contextual. You'd want a beautification algorithm to beautify you in a way when you're at the beach, and in some other way when you're at a wedding or some other event, right? It has to be personalized. The best beautification for person X does not work for person Y, and so on, and constantly adapting, right? And what do we do when we have a problem in image processing, or computer vision, and can't solve it with traditional means? Well, we apply machine learning, right? And we apply machine learning to try and augment and enhance, using artificial intelligence, our visual content, right? And that's one of FotoNation's current areas of research, turning beautification from a static application to an artificial, to an intelligent application, right? So the first step we did was to cast beautification as a standard supervised learning problem and use machine learning to solve it, right? So we have the input image, we have the features. We keep the features because they're obtained after many years of experience, but we use a neural network to infer the best values for each feature, right? And then once we get these values, we apply the beautification algorithm as is, and we obtain the final result, right? And it's intelligent, it's okay, it works. It only relies on the limitation that you have these handcrafted features, and that's something we're actively researching right now. Face beautification as a supervised learning problem. But we can go even further, and I think the beautification of tomorrow, or maybe this will be the beautification of tomorrow, but the beautification of the day after tomorrow won't use handcrafted features. It certainly won't use handpicked values. It will infer beautification by itself, unconstrained beautification. And how I see this today, and how I think it should be solved, is to cast beautification as a general image-to-image translation problem and use unsupervised learning using generative adversarial networks, or GANs, in order to translate between the domain of normal images to the domain of beautified images. And as you can imagine, that's a very, very complex problem. I would call it the holy grail of computational photography. Okay. For those of you who are not familiar with generative adversarial networks, they're one of the hottest topic in computer vision nowadays. And the idea is that there are subclass of generative models in the sense that they allow one to sample from an unknown probability distribution in order to generate new data. And how do you do this? Well, you have not one, but two networks. That's the main feature. You have a generator networks, which will try to generate beautified versions of the input image, and then instead of relying on humans and human annotators and human ranking to say, oh, that's a nice picture, that's a very nice picture, that's even nicer than the one before, we rely on some other network, which is called the discriminator. The discriminator should say, the picture you generator showed me before is not real. Make it look real. Make it look like really beautified, like the real beautified images look like. And you see, it's a competition between these two players, which are playing a zero-sum game. Anyway, as the training process goes on, the generator's goal is to fool the discriminator by supplying artificially beautified images that look like naturally beautified images, and the goal of the discriminator is to not get fooled. And as the training process goes on, both players learn and evolve, and ideally the game stops when the generator manages to produce realistic samples, and in mathematical terms, it means that the generator has learned to produce, to sample values or data from the true distribution of the data. Okay, so it's an important thing compared to supervised learning, and I think that's the way to solve this kind of problem. Generative networks are successfully applied in image-to-image translation problems. I haven't seen them applied to beautification problems, and I think that that's where we should aim, to apply them to beautify faces and to do unconstrained photo enhancement. Okay, so it's clearly a complex problem. So what we're trying to do right now at FotoNation is to break it into several sub-pieces which are easier to... Yeah.
Sorry, how does the discriminator network is trained?
The question was, how does the discriminator network is trained? Well, the discriminator receives two types of data. The artificially beautified images generated by the generator, but also, and that's the role of the human, to provide a set of real beautified images. So you say to the discriminator, hey discriminator, there's this guy, the generator, that will try to generate some artificially beautified images. You should pay attention because this is how real beautified images or real enhanced or real good-looking images look like. So, so the discriminator tries to discriminate between these two types of data, and once the generator manages to reproduce the distribution of the real beautified images, it will fool the discriminator, which cannot tell apart, which cannot differentiate the artificial and the real data.
Okay. But it's not like the same problem which is passed to the discriminator. So
the same
you
problem?
Said, yes, it's the same problem because you said the discriminator needs to be trained, supervised trained by human. So you pass the problem from the base network to the discriminator network.
Okay, so the discriminator will only receive these two types of data. And he knows, yes, the discriminator is trained kind of in a supervised way because it receives at train time, we also give him the label. Okay, this image comes from the generator, this image comes from the real distribution, from the real data. But the generator, because once the system reaches equilibrium, the generator and the discriminator, we only care about the generator. The generator is the one which will produce new data for us. Okay, so I said this is a complex problem and we try to break it into sub-problems, and we've investigated super resolution, deblur, texture recovery. Okay, I'm going to talk now about super resolution. So super resolution has always been an area of interest in image processing, but lately, due to the generative adversarial networks, they've reached unprecedented performances. And what we did here, we took the original image and scaled it down by 4x, and then upsample it using bicubic interpolation, and then let the artificial intelligence, a system called SRGAN, upsample it using machine learning. And that's the result. Okay, you see here that the high frequency details are restored. You also see the artifact, but that's because of the huge downsampling that we applied. It's 4x on each side, so it's a total of 16x. Do you remember when I said that segmentation can be used to produce bokeh effect, and bokeh effect can be produced by having a dual camera system, right? So segmentation and bokeh effect, segmentation allows bokeh effect from single camera. And in the same way, having super resolution allows you to have your 8 megapixel sensor having the same quality of a 16 megapixel sensor. So that's also something interesting here. Another example of super resolution, that's a moderate downsampling. You see here that the details around the eyes, the eyebrows, the mouth, the beard are all pretty much realistically recovered by the system. And so once we have these building blocks, super resolution, deblur, texture recovery, maybe others, we can start to upsample them, we can start to put them together and maybe do general image enhancement. Okay, if you want to talk about more computer vision and machine learning applications, come visit us after the presentation. We also have demos, face detection, body segmentation, and also some audio demos. So definitely come visit us after the presentation. Once again, my name is Liviu Dutu. I represent FotoNation, and if you're interested, we also have an event at Stagi pe Bune. We would love to have you there. Thank you very much.
Thank you. Let's take a couple of questions and then maybe move over to the demos and then take more questions over there. Okay? So, any questions right now? Let's see. Okay, yeah.
Is it right to think that some of us that have a Samsung device this evening is using your technology? Because they do have a beautification filter on the camera.
I really don't know if I can go into details with this, but we can talk more at the demo. Yeah.
Okay. Let's see. Okay, there is a question there in the back.
Hi. Two questions actually. Where do you get your training data from?
For which
And
task?
For the basic face detection, for example.
Okay.
And second, do you have any applications in future self-driving capabilities or something like this?
Okay, autonomous driving, right?
Yeah.
Okay. So the first question: where do we take our training data for face detection? FotoNation has an experience of history of 10 years of doing face detection, and we have a whole acquisition team, and we have a whole marketing team. So we do our own data, basically. Okay, and for the second question of do we intend to go into the autonomous driving, personally I would like to, but you know there's a huge gap between Mobileye and the rest of the players in this field. So entering into the autonomous driving field right now would be kind of risky, and we are doing one step at a time. We have a driver monitoring system solution, and maybe in the future we'll also have system for the front camera, rear camera, and so on. But right now, all we have is the driver monitoring system solution.
Okay, let's see if there are any other questions right now. Yes, we'll take these two questions and then we'll move over to demos.
Hey, question related to what you do, not necessarily related to machine learning, but you said that you emphasize the technology that's in the device, not on the server.
Yeah.
That's the way you operate.
Yeah.
And how do you know how many devices implement the technology? How can you control this? I mean, how do you know they don't resell your technology?
Oh.
Especially in countries in which you, I mean, not in the United States, like especially like in China or in countries where you can really enforce the patent or.
How do we know how many devices we sell? I guess we have contracts and royalties per device, and so we see the amount of money coming in, and we know how many devices they've sold using our technology. How do we enforce our technology not being copied? We have some software strategies that enforce this, meaning that it's hard for our software implementation to be broken and to be reverse engineered. But anyway, once we deploy a library, basically they can do whatever they want to. They're not allowed to. We do our best to protect our intellectual property, but I guess it's their business if they break the law and reverse engineer our solution or resell it, as you say. It's their fault.
Okay, hello. I've got a short question for you about the beautification function. What would it happen with the image if, for example, with the woman image, what would it happen with the picture if the woman was already made up, for example? And actually, what would happen with the picture if the lighting was already fixed and so on?
Yeah. So you just pointed out the main problem of the current beautification solution, right? Because the current beautification solution is static. It doesn't know if you're wearing makeup. It doesn't know if the light is perfect. And right now, what you can do is to not fine-tune, not add makeup, let's say, right? You already have makeup. You don't want to add an extra layer of makeup. But in the beautification of tomorrow, the system, the artificial intelligence, will know that you're wearing makeup or the lady is wearing makeup, and so won't add for you an extra layer of makeup. It will also know that the light is perfect and there's no need to relight the scene. So that's the beautification of tomorrow, contextual.
Okay. Thank you very much. Yeah, we'll leave it for the demos, as I've mentioned. Thank you once again, Liviu, for the awesome presentation. And we'd like to also thank you for being present here. This is our largest Bucharest AI meetup to date. Before leaving, we'd like to kindly ask you to fill out the feedback forms that you have received when